Hello students, welcome back to my channel. So in this video we will be learning about the trigonometric ratios of complementary angles. Okay, so by the definition of complementary angles we know that any two angles are said to be complementary when their summation is 0, right? So say we have one angle, so in this case let us consider any right angle triangle. So right angle triangle we have one 90-degree and two acute angles, right? And we know that the sum of these two angles will be 90, means angle A plus angle C will be always 90. So these two angles are complementary to each other, okay? And supplementary, it's 180, okay? The summation is 180. So in this video we will be learning about the trigonometric ratios of complementary angles. So first we will derive the value of the t ratios for the value of 45 degree, 60 degree and 30 degree. Then we shall learn how to solve problems if except this we are getting any other angle which is less than 90. So first we shall know that how to derive these values of 45, 60 and 30 degree. Okay, so for deriving the trigonometric ratios for 45 degree I have drawn a isosceles. This is what? A isosceles right angle triangle. So this is isosceles right angled triangle. Why so? Because two of its sides are equal. See, this AB and BC are equal. Okay, I have considered these two sides as A. So what will be the length of the hypotenuse? So hypotenuse can be, we can calculate it by the help of Pythagoras theorem. So AC will become root 2a units. Okay, so you just put you just apply the Pythagoras over here, so you will get the value of AC, that is the hypotenuse. Okay, so why question may arise that why we have taken only isosceles right angle triangle? Because only in case of isosceles right angle triangle we will be getting the value, we will be getting the 45 degree angle. Okay, so to make our calculations easier we are just considering a isosceles right angled triangle. Okay, now let's find out the values of each of the t ratios. That is, first let us consider sine. So what will be the value of sine 45? It's perpendicular by hypotenuse. So in this case this is the mentioned angle and so this will be the base and therefore this will be the perpendicular. So perpendicular BC by hypotenuse AC. See students, if you consider this angle also, then this angle, the measure of this angle will be 90 minus 45, right? So this will also be 45. So you calculate the angles, like you can consider A also, you can consider C also, angle C also. In both the cases values will come as equal, okay, because both are 45 degrees. So you consider any of the angles, it's not a problem. Okay, in this case I'm considering angle A is a 45 degree, so my this AB will be my base. Okay, so sine 45 is BC upon AC, so just put the value of BC, that is A, and AC is root 2a, so you will get 1 by root 2. So this is the value of sine 45. Cos 45, that is base upon hypotenuse. So base is A upon root 2a. So you see the values of both sine 45 and cos 45 is 1 by root 2. Okay, tan 45 is perpendicular by base, that is BC upon AB. So it's A by A, which is equals to 1. Okay, so what will be the value of cosec 45 degree? So it will be the reciprocal of this 1 by root 2, that is only root 2, and therefore sec 45 will also be root 2, the reciprocal of cos 45, right? And the value of cot 45 is also reciprocal of 1, that is 1. So see, we have got all the values of sine 45, cos 45, tan 45 and cosec, sec and cot. Okay.